Okay, so hello and welcome back to another Unity shader writing tutorial. In this one we're going to be making an outline shader, but unlike the one I made in ShaderGraph, it's going to be the proper way of doing it. The way I did it in ShaderGraph was I would take the sprite, enlarge it, and then cut out the difference so that you'd get an outline around it, but it's not the best way. This is more dynamic in my opinion, and it basically, what it does is it gets the, let's pause it. So remember, shader code gets run for every pixel. So we're going to get this pixel, for example, and we're going to check the 4 pixels around it. So up, left, down, right. We're going to check the 4 pixels, get the alpha of them. And if all 4 pixels have an alpha that's greater than 0, then we're going to leave it as the normal color. But if any one of the 4, if any of them have no alpha, so that pixel there and that pixel there, then we set it to an outline one, so all the outside ones have it. Now, there is one of the frames in this animation, this one, where it doesn't work, and the only reason I can think of it not working is because the outline of our shader, the outline of our sprite. Basically, if we go back to our sprite sheet, there is no room above the running one like that. That's right at the top of the sprite. So because it's right at the top, there are no pixels above it to check. So it just doesn't render anything. So if you're doing this for your animation sprite sheet, make sure you've got empty gaps at the top for it to work. But yeah, apart from that, it works fine. So yeah, we're going to get into making that. Before we start the video, I'll just say, obviously, if you do want to see more videos like this or any other kind of video on my channel, then obviously dropping a like and subscribe would mean a lot, as well as joining our Discord, so you can join the community and discuss Unity, shader tutorials, bots, Discord bots, whatever you want. Anything on the topic you can talk about with others and get help for, so it's a really good community. But anyway, let's get into making it. So I'm going to delete shader04, delete, goodbye, and we're going to create a new shader, and we'll call it like a tutorial 04 shader, and we're going to put that onto the material, and we're going to open up the shader. It's been changed to 10. Do you want to reload it? No. Where is it? Why is that not working? What I'll do is I will create a new shader for it, because that was the name I used for the one I showed you just then. Let's apply tutorial 04 then. There we go. We've got an unlit shader empty. So let's empty this out. Okay. So we'll start off the normal. So we'll start, remember, shader. The name is tutorial 04 slash. Well, no, sorry. It's the custom is the name of the file, the location we're going to put in. Then we'll call it sprite outline, and then we will start the shader. So properties, what do we need for the shader? We need the main texture, which is gonna I'm pretty sure we're not gonna pass one in, but when you're using a sprite sheet, it treats the sprite sheet as the main texture. So we're gonna say well, texture, it's a type 2D, if you remember, and we'll set a default to white. It needs to be a string, white. And then our other thing we want is the color. We can change the color of the outline. I forgot to mention that, sorry. So it's like that, and in the inspector I'll just call it color, but it's of type color like that. So just remember spelling, if you're spelling it with a U or an O, just keep it consistent. And we'll start off with it being fully transparent. Fully opaque, not transparent. We don't want it transparent. And then we'll go down to the sub shader. So sub shader. Let's open it up. Okay, I really dislike how this moves things around, but I'll live with it. So we'll start off with cull off, which basically means we're not going to ignore any pixels. In a 3D object, you will ignore backface pixels, usually, in a mesh, because you're not going to be able to see it unless it's transparent and other reasons. But with sprites, because they're all 2D, it's good to just have everything rendered no matter what, because it's all going to be flat anyway. And this next line I will leave for now. I'll show you what it does later. But what we're going to do is we're going to make our pass. Whoa. No, we're not. Well, we are in a second when it stops jumping around. Alright, we'll make our pass. Why does it do this? Ooh, this indentation is so weird. If any of you know how to stop it being all weird, I hate that. But anyway, CG program is the way to open it, and then end CG, and then we'll do our code here. So what do we want? We want, as usual, a vertex function. So pragma vertex vertfunc vertex func, and then just note vertex, not text. Fragment func, and we're gonna go and do include and the usual library of unity cg.cg inc. And now let's start. So we're gonna have we're gonna bring in our sprite from up here, so sampler 2D called mainText, and then we need to write the structure for our vertex to fragment. So struct v2f. Hate this. Let's go for float 4 position. Well, we use pos, which is the position. So remember, this is the variable name, and this is what we're actually grabbing data-wise. And then we need a, because it's a sprite, half to. Well, actually no, it'd be that anyway because it's UV. Sorry. We want to get text coordinate 0. If you remember from last time when I made a shader with multiple textures, we would have text chord 0, 1, 2, whatever. But we only need 0 for this because there's only one texture. Now we need to write our vertex to fragment function now that we've defined what it is. So v2f vertex func, and let's okay. So we need to come up with a type and a variable name. Now for the vertex function, you generally use v as the name, and appdata underscore base. I think this is 2D specific because I've never used this in a 3D before, and this is actually the only 2D shader I've ever written. I will probably look up why it's this and not what we usually use for 3D, but this is basically just the type of data that v is. But with our v data that we're taking in, we want to output a v2f, so we're going to define a v2f, and then we need to give it a position and a uv. So we're going to say the position is, and then we have to use the unity object to clip pos. Now, as I said in my videos, this is the Unity's new way. They didn't used to use this, but they do now. Their way of converting something from, well, mesh space as such to camera space and perspective. Basically just so we put the vertices in the right place in the world. And we need to pass in the actual vertex of the vertex of the vertices to know the position. Because remember, vertices have position, we're setting the position. Then for the UV, we're just passing in the texture coordinate, which we already have, so text. Okay, because oh, actually no, it all makes sense. Yeah, app data base v. We're not actually getting v from anywhere really as such. App data base is just the base of data that we have for vertices. So in the vertex to fragment, vertices have data. So for example, a position and whatever else. They also have text code. This isn't anywhere else in the code. This is just part of the app database. Technically, we have it here, but that's just for defining what a UV is, or like we're getting the UV. Anyway, this is just for the sake of rendering. We're not gonna. Well, I'll make it so our first goal is that we can render the actual sprite on screen. Then we'll do the part of the shader that makes it outline. So after we've written the this, we have to return O, which is basically, you know, we've made O. I think it's 0. O. As you'll see, this should still cause problems though. We now need to write an actual fragment function to render it on screen after we've figured out the vertices. So we can now take in our fixed for, which is color. And because we're using pixels, we need to get some other data, which we're not bringing in as a property, it's just data we know. So we're going to refer to the main text, which is what we bring in. We want the texel size. I explained that in a different video what it is. Just think it's to do with pixel size and texel. You know, we're throwing all these words around like pixels, textures, and whatever. You should really know what these mean already. If there are any confusing terms that you don't quite understand, then just comment below and I'll actually do like maybe a separate video, or I'll go in depth with them more. But I don't really want to waste, because these videos get quite long anyway, so I don't want to sit here explaining what everything is. Just I'll explain how the shader works. That's like the main goal in these. So we take these properties and we need to use them in our fixed for fragment func. And here we take in a v2f because we've defined it already, and it's what we take in v2f, this thing, we take this in and we call it I. And this is type color, all caps, because it's not just a name we're making, it's a proper name. And then now we need to do all the fragment stuff. For now, what we can do is we can just say half, or we'll call it C is equal to text 2D, and we'll pass in the main texture with the UV, dot UV, and then we will just return C. And then we've got NCG. Let's test it. No NCG. We do have an NCG. Have I put it in the right place? CG program NCG. It appears to be in the right place. What's the other problem? It's saying that this is in the wrong place. It's probably because that's weird. There are some weird like problems with, you know, doing all this anyway. On line 13, CG program. Did I type it wrong? CG program. That seems absolutely fine. Subshader. And this. And this. All the way down. Then I'll just format it a bit nicer. This is always the most annoying part of the video. Let's just skip ahead if you want, while I just fiddle around and try and fix this to be working. No NCG tag found. What have I done differently than normal? Oh, really? I hate myself. You were probably just pointing. Oh no. See, whenever I watch videos and then someone does a silly typo, I'm always sitting there and being annoyed that they've not found it. So yeah, you're just going to be laughing at me for being silly there. But anyway, it works now. So we're going to put our tutorial 4 material onto our thing, sprite outline. Yep, and no texture there. Well, actually, see, even if I put no texture, it even puts that in because it gets it from here. Now, material property block is used to define these values. So we're currently having a problem taking in the property of the material. If I press play, it's not just going to randomly appear. So let's go to where is my shader? There it is. Okay, so there's some other things we should add. So if you go up to here, subshader. So as I said, I think I deleted it. Call off. Okay, so there is a first problem. Basically, call off when you have a 3D, when you have a cube, for example, all the pixels that you don't see because they're behind the object don't get rendered to save, power, processing power. Well, GPU power, I guess. But with sprites, they're always going to be 2D, at least as far as I can think. Sprites are literally, by definition, 2D. There is obviously one problem here with the sprite looking like that. I mean, that should fix itself. I don't see a reason why that's happening. Though, actually, it could be because we haven't yet done this. So, blend 1 minus src alpha. Now, let's just go and tweak this. I think one thing, the reason why this isn't actually fully looking right yet is because we haven't written the fragment function properly yet. We're kind of treating it like a 3D object, right? It's like a quad where it's got the full thing as the sprite. We only want this bit, really, as the sprite. What I've just done here with the alpha thing is basically treating it as a sprite as such. Normally on this object you'd expect everything to have a color, but really you only want the bit with the sprite. Now obviously this still has the weird background thing. We're going to fix that when we write the shader. So let's get into the proper shader that you've been waiting for. So inside the fragment function, all we're doing is getting the color of the texture on the plane and returning it. That's why it looks a bit odd. So we want to first of all say C, which is just the color of the pixel returning. Its RGB value, we're going to multiply it by the alpha, which basically means that now, we got a problem. Where's the shader? Okay, saying return because I didn't put a close thingy. Okay, there we go. Now we've got rid of our thing, which basically says, if the pixel has no alpha, then just don't render it. It's invisible, This color doesn't change anything yet. Alright, let's go back to it. So now we've got a normal sprite shader, basically. That's kind of what a normal sprite shader is, I guess. I haven't looked into the default sprite shader before. But half for, we want to now sort out the outline. So we want an outline color, which is going to be literally just the color we pass in. But we're going to do stuff with it. That's why we have to get it as a variable here. Then we're going to say the outline color, its alpha. We're going to multiply it by... And that's so that we can actually change the alpha of the outline if you want to. We're going to multiply it by, and then we have to do ceil c.a because we might have, when we work it out, and when you do multiplication, it's often that you get decimals and horrible numbers. This is basically just making sure ceil means round up so that we get a whole value, because it doesn't like giving you you can't have decimals in RGBA values. Can't have decimals, so that basically sorts that out. And it means, like, now, well, I can't show you because we don't have the outline yet. So let's work out the outline. So what we're doing is, the goal of this, as I explained earlier, is to get a pixel, which is how this code works. It runs on every pixel. We want to check the alpha of the 4 pixels around it, and if any of them are 0, we want to render it as an outline color. Otherwise, leave it the same. So we're going to need to have 4 variables here. So this isn't the best way of doing it. I just thought I'd show you. So can't type, sorry. We need 4 variables, and we are going to call the first one like up alpha, down alpha, right alpha, left alpha, alpha. Oh no. Okay. These are 4 variables we want. And they're all going to be, we need to basically get the alpha. So we first of all want the texture, 2D, because it's, 2D sprite. We're going to pass in the main texture and the UV coordinate of our current pixel, which is I, the pixel, .uv. And what we're going to do is, that's basically referring to the current pixel we're on. That's all it means. That's just getting the alpha. Oh wait, if we did at the end, .a, that would refer to the alpha of the current pixel we're on, but we want to get the pixel that's up for this one. So we're going to say this plus, and then we need to refer to a fixed 2, 0 on the x, because remember we're checking the one above it, so we don't want to change the x value. We don't want to add any to the x. Think of fixed 2 here being like a vector 2 in vectors, yeah. So we don't want to go anywhere on the x, and on the y we want to go up in 1 pixel. And the way we can do that is we can say main text underscore pixel size, which is what we're on about earlier, so the size of a pixel, dot y, which is the y component of it. And remember, we're adding it, so we're going to go up, because it's 0 on the x, this on the y. So we're actually, this is getting the alpha of the pixel above us. I need to close that with a second bracket. So this line here, this value is going to be the alpha of the pixel above the current one we're checking. And if you hadn't guessed, it's going to be basically the same for all of them. But in this one, we're going to be checking it minus, so we get the same distance, but we're going to go down, negative down, positive up. And then we do the same here, positive and negative for right and left. Left is negative. But we don't want to do the x, we don't want to do the y, we want the x. But if we do x like this, we need to make sure we basically put in 0 for the y. So we're going to do comma 0, which will mean, 0 on the y. So 0 on the x, we go up y. 0 on the x, we go down y. Go up on the x, which is right, and nowhere on the y, we stay on the same y. And then this is the reverse negative here. So we're going to basically get 4 values here for the alpha of the pixels around us. So up, down, left, right. Or yeah, up, down, right, left in this case. And then before we return, we want to calculate the pixel, whether it's going to be a normal pixel or an outline pixel. So we're going to say lerp, which is always useful. We want to go between our outline color and our pixel color for the texture or the sprite. So we want to go between these two values. So what we're going to do is we're now going to put a third value after the lerp, and this is how far between them we are. So if it's 0, we're on this one. If it's 1, we're on this, and anywhere in between is a mixture. Now we're not going to get anywhere in between. It's going to be 1 or 0. So basically, if it's 0, we're going to get our outline color, and if it's 1, we're going to get a color. Now if we've got 4 values here, and if any of them are 0, we want to do it as an outline color. How do we get that? Well, as you probably know from maths, if you multiply 0 by anything, it's 0. So what we can do is we can do ceil, just for the sake of not getting any values that it doesn't like. If we take all of these values, so the alpha, what is it called? The up alpha, multiplied by the down alpha, multiplied by the right alpha, multiplied by the left alpha. If we do that, it's basically going to say dun 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 dun. So if we multiply them all here, if any of them are 0, it's going to output 0 and be the outline color. So if any of these are 0, if there's any empty pixels basically, or transparent pixels around it, we're going to give it the outline color, which is what we want. And then otherwise it's going to be, well, not 0, and because we're rounding up, it's going to go to 1, because if it's a point something, it'll be 1. Also, the alpha of all the other ones should be full anyway, to be honest, unless we have a transparent sprite. But in that case, it still will be rounded up from ceiled to 1. So 1 means C, and we get given the C, which is our actual pixel color. So only the ones on the outside get outline color, which is what we want. So if we now come back out, and I've done everything right, I haven't. Let's go check. What have I mistyped this time? What have I typed? What have I done? Can anyone spot what I've done? Wait, sorry, what does it say actually? I should probably try and fix it just from reading the error. Syntax unexpected half. Where? Oh, I didn't close any of these off. That'll be why. Yep. Now, ooh, that's a bit odd. I will see about that in a second. Well, first of all, as you see, we do get the outline color. We just also get the rest of the pixel, which is unexpected. It looks pretty cool, but it's probably not what you want. And if you press play, then yeah, you'll see also why it cuts off the top one, because it goes out of the box. But we really just want this color here and not the other one. So if I go to the shader code, I think it's something I've done here. Let me just see. Half for. Okay, yeah. We want to say the outline color dot RGB. We want to times that also by the outline color, the alpha of it, so that we basically get that to be the right alpha, and obviously transparent alpha. Yeah. So now we can choose any color, and we can change that dynamically. You could have it in code so that it's constantly changing the RGB values, and it's just like a insane rainbow looking thing. You can do whatever you want. You can change transparency or just change color depending on, you know, enemies might have a red outline for a bit or something. I don't know, whatever you want. But anyway, as always, these videos drag on quite a bit. This tutorial was actually asked for a lot of people, so I hope it's helped. And obviously, if you know people who might be making 2D games and they want to, you know, have a shader like this, it's really helpful. Rather than taking all your sprites and, you know, putting outlines on them pixel perfect, this saves a lot of time and it's dynamic. You can change color mid runtime. It's so much more. It's so much more sensible and, you know, better to do this. But anyway, yeah, if anyone wants to, you know, use this and go ahead, you know, it's not mine. No one owns shader code. Everything anyone learns pretty much is from looking up online at like tutorials. Like I've started learning and understanding how it all works now, and I'll be slowly going through all the requests I got for shader graph and now making them in coding shaders because they're only really possible in this. But anyway, video's dragging on. If you liked it, then obviously leave a like and subscribe. It'd mean a lot. Share it with whoever you think might, you know, benefit off this. If you want to join our Discord, I've said all this at the start. I'm not going to bother wasting your time now. Thanks for watching. It means a lot. Close to 1,000 subs. Going to make it eventually. Going to be good. Thanks for watching, and goodbye.